Some of the common questions that kids ask are, why is the sky blue while the clouds aren't? Why is the sun yellow? And why does it turn reddish-orange during sunrise and sunset? These questions might look difficult to answer at first. However, the physics behind them is not difficult at all. There are two things that play an important role in giving a color to the sky. One is the atmosphere of the earth, and the other is the sunlight, of course. So we need to know more about these two first. The white light coming from the sun is a mixture of 7 primary colors, and each colored light has a corresponding frequency and wavelength associated with it. The violet-colored light has the shortest wavelength of all, while the red one has the largest wavelength. And what forms the Earth's atmosphere? The Earth's atmosphere is mainly composed of gases, dust particles, water droplets, and water vapor. Among the gases, nitrogen is present in abundant quantity at around 78%. It is followed by oxygen, which is approximately 21%, and the remaining is filled with the likes of argon, carbon dioxide, and other gases. First, let's see what happens when the sunlight falls on these air molecules. When sunlight strikes these molecules, it gets scattered. Scattering is a process in which the light is absorbed by the atoms and re-emitted back in various directions. However, not all the light is scattered equally. The amount of light that will be scattered is given by the Rayleigh law of scattering. It says that the amount of scattered light or the intensity of the scattered light is inversely proportional to the 4th power of the wavelength of a wave. I is inversely proportional to lambda to the 4th power. If the value of lambda increases, then the intensity will be lower. If its value decreases, then the intensity of scattering will be more. Lesser the wavelength, more will be the scattering. So now, I want you to tell me, among the 7 colors of sunlight, which one will be scattered the most? Yes, the light of the color corresponding to the smallest wavelength will be scattered the most. So blue, indigo, and violet light will be scattered most by these molecules of air. And when this light travels to our eyes, the sky appears blue to us. But wait, the violet light has the smallest wavelength. Then why doesn't the sky appear violet or even indigo for that matter? It is true that the sky scatters the violet light more than the blue light. However, we don't see violet sky, do we? What's the reason? The following graph tells us how much of a particular wavelength is emitted by the sun. Observe the graph well. As you can see, the sun emits more blue and light bluish light compared to the violet light. Hence, more blue light is scattered by the air molecules, resulting in the blue color of the sky. And another reason why we cannot see violet light is because our eyes are more sensitive to blue light than to violet light. So this was about how the gases present in the atmosphere scatter light. Do dust particles and water droplets also scatter light? Yes, they do. They scatter light as well. However, their size is comparatively much bigger than the size of the light waves. And hence they scatter all the colors of light in equal amounts. So the white light which is entering the cloud or the dust particles emerges out as white light again. Hence the clouds appear white. There's one last question we need to answer. Why does the sun appear reddish during sunset and yellow otherwise? We will see that in our next lesson.